Hey guys, today in this video we're going to talk about hydrocarbons. And hydrocarbons are a very common type of molecule, and they really only have two kinds of atoms in them. They have hydrogens and carbons. That's, that's why they're called hydrocarbons. Now, most of the time, hydrocarbons are used as a fuel source, and all they are chains of carbon atoms, and then we have hydrogens kind of hanging off of or bonded to the carbons. So the simplest one would simply be to have a carbon atom here, and then since carbons have a bonding capacity of 4. That means that they always need to have 4 lines coming out of them. And since hydrogens have a bonding capacity of 1, they only get 1 line coming out of them. And this gives us a molecule that has a formula of CH4, and that is our buddy methane. Now, for all of the hydrocarbons that we talk about that do not contain any carbon-to-carbon double bonds or triple bonds, the ones that only have single bonds are in the category called alkanes. So here's methane, CH4. The ending of the word, that suffix ane, tells me that there are no carbon-to-carbon double or triple bonds. And the prefix, the starting part of the word, gives you a clue to how many carbons there are in the main chain of the molecule. So I'm going to do another example. We'll go up by 1 for now. So let's take a look at the next molecule in the series, and this guy has 2 carbons in a little chain. Sorry about that. We had a little bit of a cat interruption, but we're back to business. So we've got 2 carbons. There's no double bonds, and remember, all of the other bonding capacity, the other bonding spots in the carbons are going to be filled with H's, with hydrogens. So if we count everything up, this guy has a formula of C2 because there's 2 carbons and 6 hydrogens, so that'll be H6. And this molecule is called ethane. And it's still an alkane. As a matter of fact, the eth, ETH prefix means that there are 1, 2 carbons in the main chain. So nothing tricky so far. Those of you who took Science 20, this is more of a review for you. For those of you who did not take Science 20 and came in from the bio route or the physics route, not many of those though, this is new for you. So that's why I'm going to start from first principles. We're going to start naming more complicated versions of these in a bit. I'm going to do one more of the alkane group here. Every time you add another carbon, you're adding extra hydrogens. You're adding 2 more hydrogens. So this guy's going to have, instead of 6, it'll have 8. And we go. So 3 carbons here this time, so not C6, C3, and then 8 hydrogens, so H8. And you might have noticed on the right-hand side, I've got the table that tells me information about all of the alkanes that go from having 1 carbon in the main chain, CH4, all the way up to 10 carbons in the main chain, that's C10H22, decane. But we're only on number 3 right now. I'm not going to obviously do all these. I don't think there's really any worth to that. But again, we're seeing a pattern. The prefix is prop. That tells me that there's 3 carbons there. And the suffix or ending word is ane. That means there's no double bonds. So naming straight chain non-branched alkanes is absolute cake. There's only 10 that you're on the hook for. You don't need to memorize them. They're in your data booklet. So that's kind of nice. So let's just nuke all this. Let's talk about branching. So you may have noticed that since carbons have the capacity to do 4 chemical bonds, they can connect to a whole bunch of different kinds of atoms, and we're going to see later on in the next week even more variety. We're going to talk about like what happens if there's an oxygen in the mix, what happens if there's chlorine in the mix. We're going to talk about more kinds of organic chemicals, organic molecules that have mostly H's and C's, and then a little sprinkling of a couple different atoms that are going to be bonded to them. But for now, let's do a branched molecule. And I'm going to start with this guy right here. And I'm just going to put little tickies for hydrogens instead of drawing all the H's. It's very time consuming, and the bigger the molecule, it gets to be absolutely ridiculous. So I'm going to put a branch. In other words, there's a straight line of carbons here, but there's one sticking off the side here. Now we need to be able in Science 30 to name a molecule like this. And again, if you took Science 20, you're familiar with how to do this, and this is a review, but if you haven't taken Science 20, you're going to be kind of thrown in. I'm not going to throw you into the deep end. We're going to wade in. So the requirements, the things that you need to be able to do is name the longest chain. What I mean by that is find the longest chain of carbon atoms that, like, without counting branches. The second thing we need to do is describe any branches. This means tell me what kinds of branches there are. The third thing is describe the location of branches. In other words, I always like to say that parts of molecules have addresses, where, just like how houses have an address. So we not only have to say what kind of branch there is and how many of those branches there are, but we also have to say where are the branches. So with that said, I'm going to color code what I'm doing here as I write the name. So I look at this molecule here, and I'm just going to try to find the longest chain. In other words, again, the longest chain that has no branches, because I can't like do this and then be like, oh, there's a branch here. No, we want an unbroken line of carbons. They don't necessarily have to be left to right either. That's something that is a big thing. Sometimes, and I'll do an example in a moment, they get a little bit weird and you have to kind of use your brain. Teachers like to mess with students in that way, and it's not to mess with you, it's to see if you know what you're doing. And there are always students who will be tricked because they weren't paying attention and they didn't do practice. They'll just read left to right. They'll be like, oh, there's 4 carbons here. And it's like, no, there's like 6 carbons. You just didn't read. You just went left to right instead of investigating and looking carefully at the molecule. But that said, this one has, there's 2 possibilities for the longest chain. We could either go like this, because that's 1, 2, 3, 4, 5, or we go like this, because that's 1, 2, 3, 4, 5. I'm just going to do this straight across for the sake of argument. Now we look at the number of carbons in the main chain, and it is 1, 2, 3, 4, 5. A 5-carbon chain with no, without taking into account the branches, is pentane. So I circled it in red. I'm going to write the word pentane. So that takes care of the longest chain. But there's more work to do. There is a branch. See how this carbon is connected to 2 carbons. We've already got these ones all taken care of and described, but we have not talked about this guy up here. So this is what we call a branch, and you're going to be seeing more and more of these. We're going to do a couple more examples of branched hydrocarbons in a moment. There's going to be a separate video about double and triple bonds that I'll be putting up early in the afternoon today, okay? But for now, let's focus on what we're doing here. So this is a single carbon, and if we look here, the prefixes meth, eth, prop, bute, pent, etc. The prefixes are what tell me how long something is, how many carbons it's got. And I look at this and I say it's got 1 carbon. Because it has 1 carbon, it has the prefix meth. But it's not methane. Why isn't it methane? Methane is CH4. It's a molecule. This is not a molecule on its own. It's like a little piece of a molecule. And pieces like this, they get their own special ending word, which is methyl, or il, Y-L, is the name of a branch. So if I write methyl right here, and it's going to be 1 word. So methylpentane. If I write that, now I'm saying, hey, there is a methyl group on my pentane. The last thing we need to do is describe the location of the branches. So if I look here, there's 5 carbons in a row on my main chain, on the pentane. So what I'm going to do is I'm going to basically give all of the carbons addresses. And the goal here is to make sure that the numbers that I use for the addresses are the lowest that they can be. So I'll give you the wrong answer first. If I number these carbons like this, carbon 1, 2, 3, 4, and 5, if I describe the location of my methyl group, in other words, hey, where is the methyl group? It would be on carbon number 4. So I would write 4 dash methylpentane. But that's wrong because there's a better number that we can use. And I just realized that I can't get rid of... Oh, I can. Beautiful. If I number these the other way, 1, 2, 3, 4, 5, I get 2 methylpentane. And 2 methylpentane is the correct answer because it's got the lowest number for the branch. Another thing that teachers that I may do on a quiz or on a worksheet or something, when we go to drawing these, something that I might do is give you a name that's intelligible. In other words, give you the name of a chemical that makes sense. But then you follow the directions, you draw the molecule, and it turns out that the name is wrong. If I asked you to draw 4-methylpentane, guess what? It's the exact same as 2-methylpentane. The name is wrong, but you could still draw the molecule. It still is intelligible. It makes sense. So let's do a couple more examples. A couple more examples here right quick. I'll use the medium here. All right. So let's move on. Let's do another molecule. I'm going to do a 6-carbon main chain this time. 3, 4, 5, 6. And I'm going to throw, I don't know, let's do a 2-carbon chain or branch. I fill in the rest of the spots with little dashes to represent hydrogens because, yeah, you really don't want to draw hydrogens if you don't have to. There we go. So now we look at this molecule and we go through just like we did before. So I look here, and this is just, again, for example's sake. So I look here, and we've got 6 carbons. I don't think there's any other way to do it that would be... Oh, we could also go like this, because that's 1, 2, 3, 4, 5, 6. Sure. Is it going to change anything? I don't think so. That's the nice thing about these. So we'll go straight left to right. So we have 6 carbons. So 6 carbons is a hexane. That means that the ending part of my word is going to be hexane. Now we have to describe the branch, the type of branch. And it is a 2-carbon branch. A 2-carbon branch would not be ethane, it would be ethyl. So I'll throw ethyl in front here. So we've got ethyl hexane. Now we have to talk about where the branch lives. So it could either be 1, 2, 3, 4, so 4 ethyl hexane, or it could be 1, 2, 3, 3 ethyl hexane. Since 3 is a smaller number, we're going to go with 3 ethyl hexane. So again, the only time that you're going to see numbers, like actual digits, numerals, the only time you're going to see those is when they are describing the address. You don't use numbers for anything else. When we talk about how long something is, we use meth, eth, prop, but, pent, hex, hept, oct, non, dec, the prefixes. When we talk about how many of something there are, we're going to use another set of numbers. Not numbers, but words that denote numbers. So I'm going to scroll down here, and I'm going to do a molecule now that's got branches, but more than one branch. Sure, let's go with this guy here. I'm going to throw a single carbon branch there. And I'm going to throw a 2 carbon branch here. And then, of course, ticky marks for all of the hydrogens to save some time. Beautiful. Okay. So everything is the same as it was before. So we still are looking for the main chain. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It turns out it doesn't matter. If there are 2 options for the main chain, you could pick either one. So I'm going to get weird with it. I'm going to do this one this time. They're still in a straight line, or they're still all connected, and I haven't branched at all. So this is still allowed. So we have 7 carbons. That means that the molecule name is going to be heptane. And now we have to look at some branches. We have to talk about those guys. Remember, this is a methyl group. And this guy is an ethyl group. And they both live on, let's see, looks like carbon 3 to me. 1, 2, 3. So these guys both live on carbon 3, which means this is a 3-methyl, and this is a 3-ethyl. Now we have to put these into the name. And one thing that is important is that we use alphabetical order. Yeah, I know, they keep adding little things into what you have to do. It's going to get worse, but it ends up, this is not too bad. So ethyl, 3-ethyl comes first. 3 dash, get my blue out, ethyl. Then we have a dash. We always separate numbers from words with dashes. And then 3 dash methyl. Heptane. And let me just move those words over so they look like they're one word, because it should be one word. So 3-ethyl, meaning there's a ethyl group on carbon number 3. 3-methyl, there's a methyl group on carbon number 3. Heptane, there's 7 carbons in the main chain. So not too difficult. I'm going to give you one last example. And I'm going to come back up here and just kind of delete some of this. Clean up the zone a little bit. There we go. So now we will do another molecule, and in this case, there's going to be a lot of branches. I'm going to do another heptane though, because heptanes are nice and easy. 1, 2, 3, 4, 5, 6, and 7. So let's put some carbons like that. And you know what? Let's put a carbon like that as well. So you can maybe see what we're doing here. We've got 1, 2, 3 methyl groups. And now I'm just going to make the little dashed lines. Notice here, these are not connected. They are not connected, folks. We've had sometimes, I remember one or a couple students last semester, they thought that this was one line. That's a different kind of molecule altogether called a cyclo because it's a ring. We're not talking about those right now. So we've got all of our carbons, we've got our little hydrogen tickies. Now we can draw our main chain, and this is just straight left to right, 7 carbons. So that's going to be called heptane. And now we have to describe branches. Hey, look, there's one branch, there's another branch, there's another branch. How many methyl groups do I have? I have 3. When there are 3 methyl groups, we use the Greek numbering system. The Greek numbering system is also in your data booklet. It is mono when there's one of something, but we don't worry about that in organic chemistry. Then di is 2, tri is 3, tetra is 4, then penta, hexa, hepta, octa, nona, and deca. So yes, you can end up having like decamethyldecaine. That's a thing that could happen. Will you see that in Science 30? No, but it's a thing that exists. So I'll write down my trimethyl here. Running out of space. Trimethyl. So we have trimethyl heptane. We've described how many of the methyl groups there are. Now we need to give the addresses. And the addresses, remember, have to be the lowest number. So there's 2 options. We can either go 1, 2, 3, 4, 5. So this would be 4, 4, 5, trimethylheptane. Or we could go left to right, pardon me, which would give us 3, 4, 4. Notice that I said 3 numbers there. I said 3, 4, 4. You have to put numbers for each of the branches. I can't just say 3, 4 trimethylheptane. Why? Because that doesn't tell me which one of the carbons has 2 methyls on it. If I just say 3, 4, what about the other methyl group? I haven't talked about it. So 3, 4, 4. So we have 3, comma, 4, comma, 4, dash. So 3, 4, 4, dash, trimethylheptane. Oh, one last note about branch names and numbers. And it is this. Branch numbers are only important from butane up. What do I mean by that? If I do this molecule here, put my little tickies out there. This is a propane. And yeah, we can see that there's a methyl group on there. So methyl. And you might be feeling like, hey, Lorenz, should I put a 2 because it's on carbon number 2? Here's the question I want you to ask yourself. Is there any other place that I could put this where it would still be a propane? And the answer to that, of course, is no. If I put this little methyl group on the end, it wouldn't be propane anymore. It would have 4 in the main, so it would be butane. So that means that this name, methyl propane, is unambiguous. Ambiguity is when you can read something more than one way. So if it's unambiguous, that means that the only way to make this molecule, the only way to follow this instruction would be to make this molecule here. So there's no such thing as 1-methylpropane because that would be butane. There's no such thing as 2-methylpropane because literally the only place where you can put the methyl is on carbon number 2. So I hope that clears things up a little bit. In the early afternoon, I'll be putting up a video where we start throwing double and triple bonds into the mix. And, well, I won't get ahead of myself. You will see the video when it's recorded. It's not too difficult. As always, if you have questions or concerns, make sure that you put them in the comments of the stream, not in the assignment. If you're in your Google Docs and you're writing an assignment and there's a place that says post comments, I cannot see those until I check your work. And I'm not going to browse through everybody's work to see if they asked a comment. So put your comments on the main stream. That is the most appropriate place to put them. As a backup, you may email me, but only if nothing else is working. And please, when you do email me, make sure you use your school email address. I don't want coolguy2001@hotmail.com emailing me, please. I want whatever your student number at ecsd.net emailing me if you need to email me. All right, guys, hang in there. I hope this video clarifies what we need of you for organic chemistry. So see you next time.